Alright, Matrix Transformation Human Centered CAD Lab, March 26, 2009. This is Seal Nation University Computer Aided Design, Lecture 5, Matrix Transformation. And then we are recording. Okay, so Matrix Transformation Human Centered Lab, Computer Aided Drafting Laboratory, March 26, 2009. Transformation mapping calculates world coordinates of the points of the modeling points on a model when or it's the model coordination system is translated and rotated. Transformation model view matrix mode open graphic library calculates viewing coordinates of the point on the model from where the coordinates from calculates viewing coordinates for the points on the model from their world coordinates. Result is mapping the graphic library projection matrix mode open graphic library. So we have X width XMA, X width YMA, X W ZMA, and so your X, Y, and Z W's are your world coordinates, and then you have your material coordinates X, Y, Z, M. Translation coordinate with the two sets, Z world, Z material, Z world, Z model equals 0, or 3x3 transformation. So on the left we have a homogeneous 1x3 matrix, homogeneous, and those are your X, Y, and Z coordinates, and they're equal to 1. You have your translation A, B, and C. Homogeneous transformation matrix. On the right, you have X, Y, and Z model, and they're also equal to 1 in the 4. So, delineated line to the right, quadrant 4, A, B, C on the far right hand corner, and then the zeros is the A, B, and C language. Your rotation shows the X, Y, and Z world coordinates, quarter turn, and then rotation, Y world cosine, 0A L cosine, length cosine, 0A length cosine, cosine A minus sin A, cosine A, sin A, cosine sin. Z world sin cosine sin cosine, and then Y Z sin Z model cosine. Alright, now we've rotated the left is your world coordinates. Y to the far right you have your X, Y, and Z models. And then in the middle we have a cosine to sin, and then the sin to cosine rotation, and that's on the x-axis. So x would be 1, and then on the 1, and then you'd also have 1 for the value. Rotation on the y, rotation on the z console. Rotation are about arbitrary axes. X, Y, Z world, X, Y, and Z world, parameter 1, parameter 2, X, Y, and Z model. Rotation arbitrary axis is substituted A, B, C, substitute B, C into A. And substitute Q equal to parameter times N to the D. Rotation about arbitrary axis. Continued rotation world coordinates X, Y, and Z 1. Rotation N to the 0 to X's value N to 0. X, Y, and Z model 1, rotation N, and it shows the three different matrices that are between in this 4x4 matrix. Alright, example 1. What object translated 5 units in the y direction of the world coordinates, then rotated 90 degrees x-axis world coordinates? What are the world coordinates point 0, 0, 1 in model coordinates? Once again, it's X, Y, and Z world coordinates, X, Y, and Z world coordinates, X, Y, and Z world coordinates 1, 1, 2, 3, 4, 5, and then a 1 to 1. So, example translation, X, Y, and Z world 1, translation 0, 5, 0, 1. And then we have a times matrix 0, 0, 1, 1 equal to 5, 0, 5, 5, 1 rotation. Rotation XY Z rotation 90 degrees equal to 0, 5, 1, 1 equals 0, 1 4 by 4 matrix 0, 5, 5, 1 or equal to 0, negative 1 B 5 1. Examples A, B, and from A and B, we have X, Y, and Z world coordinates rotated at X 90 degrees. Translated translation 0, 5 to 0. Condense the constant satiation times double 0 X Y zeros Y Z Y's. Example 2.001 is rotated 90 degrees about an axis, point passing 032 in XY direction. Then it shows the matrix translation 032, rotation x 90 degrees, translation 0, negative 302. Scaling transformation, scaling X, Y, and Z. Scaling with X or T, X, P, P, P. Translation of scaling WRPT scale and translation. WRT XY plane. Reflections of the WRTP YZ plane X planes are similar derived. Model transformation, object, graphic language, void, graphic library, matrix model, graphic library model view, select matrix to be transformed. Void graphic language, translate type X, type Y, type Z, translate model by X, Y, Z. Void graphic library, rotate effect, type angle, type X, type Y, type Z, rotate model by angle, degree about vector. Void graphic library, scale function, type X, type Y, type Z, scaling by ratio X, Y, and Z in each axis direction. Mapping, convert coordinates of world coordinate system into the viewing coordinate system. Void graphic library, matrix model, graphic library underscore projection is command. Graphic void graphic library. You look at graphic level of double X, EIXIYIZ. Center X, double entry, graphic library, union, double century, union, central Z, double up X, double up Y, double up Z. Mapping, continue to let T1 to T12 be transformation matrix coordinate value of WRT, X2, Y2, Z2 coordinate system through the WRT XYZ1 coordinate system. XYZ2 1T equals T to 1 2 XYZ 1T. Derive T1 after A expression equations as follows. XYZ2 on the left side, and then N equals in the right side your matrix, and we're XYZ1. We have in the left, and then N X Y Z L O X Y Z A X Y Z P X Y Z. Mapping, substituting x1 0 y1 0 0 1 0 gives x2 equals px, y2 equals py, z2 equals pz, px, y, z, planes x, y, and z. Coordinates are origin x, y, and z one frame. Substituting x1 1 y1 0 z1 0 but into gives x2 equals numbered x plane number plus plane x y2 equal nx y plane y z2 equal n numbers z plus plane z. NX, NY, NYZ are X2, X2, YZ components of unit vector X along its axis O X, O Y, O Z, X2, XY2, XZ2 components of unit vectors along Y1 axis, AX, AY, AZ, or X2, X2, Y2, Z2 components of unit vector along Z axis. Example point viewpoint and negative. You have X is negative 10, Y is 0, 1 to 1, Z is 1. View site is X, Y, X and Y 0, 1, G up to vector X and Y 0, 1. 2. Where are the X vector, Y vector, Z vector of X5, Y 0, 1. Z and world coordinates, and we have a world view and vectors, and then it shows NOAP, AX, top X, second row down Y, third row Z, fourth row numerical coordinates. Isometric views, viewpoints, or 5 to 5 to 5 view sets, 0, 0 to 0, up vector of 0, 0, 1, showing view coordinate system derived of the T world and vectors, X vector, Y vector, Z vector, 0, X, Y, X and Y 0, Z 5, and then it shows the viewpoint. Example 2, and then it has some algebra, IJK. X vector components on the X world axis, Y vector on X world axis, Z vector components of X world axis. Examples. And then that is basically a rough look at matrices. You might need to study some matrices. I do.